All right, students. So this is hopefully going to be a bit of a review. It's the metric system. Hopefully you've heard this at some point. We're going to talk about some of the base units of measurement. If you need to measure length using the metric system, you would use the meters, which has a symbol of a small m. If you're doing mass, you're going to do grams, which is a small g, as the base unit. If you're doing volume in the metric system, we're going to use liters, which is a capital L. And that's equal to, if you had a decimeter by a decimeter by a decimeter cube, then that's how we got a liter. So it's 1 decimeter by 1 decimeter by 1 decimeter. Anyway, all right. And then time, if we're measuring time, we use seconds, whatever. This is where it starts getting a little. And then this year, we'll be talking about the amount of chemicals. The mole is what we use to talk about the amount of chemicals. So that's a base unit as well. And energy, we use the joule. All right. So here are prefixes you should have seen before in your life. The ones we're going to focus on are these middle ones. I'm reasonably certain here. So mega is a lot of base units. So it's 1,000,000 base units. So if you have grams, it would be 1,000,000 grams to be 1 megagram. If you had liters, it would be 1,000,000 liters to have 1 megaliter. Kilo is more familiar, right? Anyone who runs a kilometer knows that's 1,000 meters. So kilo meter means 1,000 meters. Kilogram means 1,000 grams. So when I'm saying this X is the base unit. And then the smaller things, centi, milli, micro, right? So centi is 1/100th of whatever you're talking about. So 1 centigram is 1/100th of a gram. 1 centiliter is 1/100th of a liter. Milli is 1,000,000th. So 1/1,000 grams is a milligram. Or you can turn it the other way around, which is what I do here, where everything's positive. So here, right, 1,000,000 liters equals 1 megaliter. 1,000 grams equals 1 kilogram. But on this side, 100 centimeters equals 1 meter, or 1,000 milliliters equals 1 liter, or 10 to the sixth, or 1,000,000 micro equals 1 base unit. So either way you want to do it should work, but those are the ones we need to know, mega through micro. If you need nano or giga for anything, I'll just give that to you so you don't have to worry about it. All right. So here's how we're going to do this metric stuff. We're going to list what's given. It's usually going to be the thing by itself, and we're going to determine what's needed, and we're going to cancel the units using conversions. And then you multiply the tops, you multiply the bottoms, and divide at the end. And don't forget your units and how many sig figs. So this is similar. If you've watched Dora, it's always about where are we going? Okay, so where are we going and where are we starting? So in converting grams to milligrams is something that when I was in industry used to really annoy me. Let's think about if you're looking at the three schools here on Pride Way, right? There's the high school, there's the middle school, and the lower school. So lower school are like the milligrams. So if I had something like 600 milligrams and I needed to convert that to grams, well, I need to move that decimal one, two, whoops. Get rid of that. All right. So like I went there, and I went there. I did 3 jumps. 1, 2, 3. So in grams, that's 0.6 grams. Likewise, if I had like 1.7 liters and I needed to convert that to milliliters, I'm going to change the color of that so that you can tell I'm not talking about grams anymore. 1.7 liters. So that's in the big school, and I had to go to milliliters, which is a small school. I'm going to move that decimal 3 places, right? From high school to middle school to the elementary school. I'm going to get 1700 milliliters. So you should be able to go milli to grams and grams to milli or whatever, the base unit. You should know milli for sure. And it's 3 jumps. All right. So anyway, conversion factors, things that are equal. So all those things that we just saw here are going to be helpful for getting us to our answer. Now, I know a lot of you learned that kind of stuff, But we're going to use what's called dimensional analysis a lot in this class. So if you use it here, it'll help you understand that. So here, if we had to convert 500 meters to kilometers, so let's imagine the meters is red, right? And the kilometers is green. So we're playing this game where we start with red. And in order to get to green, we need to use this domino. And this domino needs red at the bottom and green at the top in order for that to get converted from red to green. So that allows the red to cancel and the green to stay up. So if we have 500 meters, which should be in red. So if we have 500 meters, then we know there's 1,000 meters in 1 kilometer. That's going to allow us to cancel meters and go to kilometers. Then 5 times 1 is 500. 500 times 1, and then 1,000 times 1 is 1,000, and 5 divided by 1,000 is 0.5. All right. So this is how it's helpful to understand for chemistry to do this. So this is just like if I say you've been traveling for 3 hours at 55 miles an hour, how you figure out how many miles you went. All right. So the base unit is important to do all this. There we go. All right. So there we go, kids. We got to do the base as sort of like a landing spot. It's kind of helpful. Okay, so we're going from centiseconds to seconds. We know that 100 centiseconds equals 1 second. That we should memorize because that's one of the ones I told you should know. So therefore, if we're starting with seconds, if we're starting with the red, this domino we're going to want so that the 1 second is at the bottom and the 100 centiseconds is on the top. That's how we're going to want to use that information. So what you see here is I got seconds on the top. The domino I use is with the blue on the top and the red on the bottom, so those reds will cancel. Then we multiply 45 times 100 divided by 1, and we get 4,500 centiseconds. So for this next one, using what Megan Trainor just taught us, if we want to go from kilograms to milligrams, we should know the relationship of kilograms to grams. And you can either know that it's 1,000 grams in 1 kilogram or 1/1000th of a kilogram in a gram. Either way works. I like to keep things positive. And we also need to know the milligrams. So this is one of our dominoes that we can use to do our canceling. Here's one. And the other domino is going to involve grams and milligrams. And in this case, it's 1 gram is equal to 1,000 milligrams. And I forget what color I did for milligrams. I did orange. So 1,000 milligrams. So those are the dominoes we can use. We're starting with milligrams because that's the number given. So we're starting with that orange. We want to cancel milligrams. So we want to use this domino and we want to put the milligrams at the bottom and then that puts the grams on the top. I did not do the right colors there. But anyway, ignore that. So milligrams cancels and then grams is on top. And then we want to go from grams to kilograms. So therefore with this thing, we should put that 1,000 at the bottom and then the 1 on the top. And that'll cancel our grams. So then you multiply 5102 times 1 times 1 and divide it by 10 to the 6th. So 5102 divided by 10 to the 6th gives you 0.005102 kilograms. All right, so let's try another one going to nanograms. So if we have 4.58 times 10 to the minus 5 kilograms. So hold on a second. So we're going to need the kilogram thing. Well, actually, I can do that. I'm going to do that. All right. So given is 4.58 times 10 to the minus 5 kilograms. Our equivalents are that 1 kilogram equals 1,000 grams. So we're going to have to hold on to that information. There's one of our dominoes. And then our other domino is that 1 gram is equal to 10 to the 9th nanograms. So that's our other domino. So when we're setting this thing up, we're going to want to use this first domino here. And we're going to want that green one on the bottom to cancel the kilograms. So we're going to put the 1 kilogram down here. And we're going to put the 1,000 grams on top. That'll get rid of that. Kilograms. And then now we got to use this domino, and we want grams on the bottom. And then we're going toward nanograms, so we want that 10 to the 9th nanograms on top. That'll cancel grams. So this is 4.58 times 10 to the minus 5 times 1,000 times 10 to the 9th. So that's 10 to the 3rd, and 10 to the 9th is 10 to the 12th, and 12 minus 5 is 10 to the 7th. So you get 4.58 times 10 to the 7th, right? Minus 5 plus 3 is minus 2. Minus 2 plus 9 is positive 7. And that's going to be divided by 1. So therefore, it's just 4.58 times 10 to the 7th nanograms. All right, so that's how you do that. We use the base, though, like Megan Trainor was saying, right? This base unit is helpful. So then if we were doing micrometers to centimeters, we're going to need the equivalents using meters now, that 1 meter is equal to 10 to the 6th micrometers. And then we're also going to need to know that 100 centimeters equals 1 meter. So these are our dominoes. The given is centimeters, the 150. So we're going to start with 150 centimeters. Of those two dominoes we have, we want to use this one because that has centimeters in it, and we want to put that dark blue at the bottom and put our base on the top. That'll get rid of centimeters, and now we got to use this domino, and we want meters at the bottom so that we can have our micrometers on the top. And then we're going to multiply 150 times 10 to the 6th. So that's 1.5 times 10 to the 8th. And we're going to divide it by 10 squared. So that becomes 1.5 times 10 to the 6th micrometers. And that's how you do it.